Hi everyone, it's Mike Levin, Friday, June 17th at about 9:15 p.m., 2016. Do people say that anymore? Quarter of? Yeah. So anyway, I'm old school, so you fucking quarter-inch floppies. I'm on my way to the Catskills to meet Addie for another great weekend of fun and adventure. And we're hanging out more at this other little town up there called Smallville, which is on this beautiful little lake where her grandparents have a place. And that's where I'm going to meet her now. It's very interesting. And lately, I've been falling in love with Jupyter Notebook, previously IPython Notebook. Who would have known that there was this category of software known as notebooks that kind of embeds what you're coding along with the data set and notes that you type all in one location so that you can sort of go back and inspect process. And this one was developed for Python and then has subsequently been extended to other languages. But I think it's primarily and popularly used for Python. I think it supports R, and the point of it is for accountability, for following process, which is something that, aside from, say, a source code repository system like GitHub, there's not a lot of actual process tracking in regards to real data in software development work. You can look at your database backups, but the data itself is very often not made part of the Git repository, or else the history of the code would look all crazy because the data changes at a much faster pace than the program code, the part of it that knows about the data and interacts with it and produces it. So, IPython Notebook. When you run it, the whole input data set is sitting there locally, and then the output data set is written as a JSON file that again is sitting there locally, so you can see exactly what code you ran from exactly what file and exactly what output it produced. And it's a completely legit Python execution environment running in a web server context, much like Pipulate. In fact, there are a lot of things about Jupyter Notebook that are like my super ultimate dream vision for Pipulate. How closely the context is intermingled between using a web browser and having Python code display on the screen that you can immediately turn around and execute, that interacts with data from the real world in all sorts of ways. It could be sitting on your local hard drive. It could be fetched through any one of many APIs, pulling data in from Amazon S3 through the Bodo package or module. And so these terms, package, module, library, they all seem to be thrown around fairly equally, and they are fairly equal. I'll use them interchangeably. So your data can be pulled in from outside data sources. It can be local text files or log files being parsed locally. You can also generate data locally. So if you hit some data source and you do a crawl and you want to record, say, title tags, but you don't want to record all the HTML of the pages you visited, you can drop the HTML or even the objects, the request response objects, into a persistent pickled object in Python terms. And really, when you think of database stuff, for the most part, it's to be avoided. Databases are what you use when the data you're producing and manipulating exceeds your ability to conveniently store it, keep it safe, and especially if it's critical, if you want it a year or 2 or 10 down the line, you need a real database. But it has a level of commitment. There's whole fields and professions around keeping them running, optimizing them, keeping their performance going, the snipping and pruning and tender love and care, because if you let a database take data in and grow forever, well, unless you're expanding the storage constantly, you're one day, and the technology, the scalability of the technology connecting to it to be faster, to be able to interface with more data, you're eventually going to have some real trouble. So there's all kinds of ways to chop data off a database, archive what you don't want anymore in some place like long-term memory, and then everything else is kept in a place where you can get to quickly. And then there's this whole difference between raw data, which is oftentimes very voluminous, could fill up your database or your hard drives very quickly, and aggregate or summary or analytically distilled data. And the distinction between the two are often being blurred because processes that generally could not be done in real time, like getting counts, aggregate roll-ups across billions of records in real time, was considered ridiculous. Now it's being done as a matter of course in products like Amazon's Redshift database, which is built on Postgres or PostgreSQL, or SAP HANA. I was the SEO for SAP for a brief period of time and did my education on their offerings. It's really interesting to get an idea of the world of proprietary. And you know what? When an open source database, a free and open source database like Postgres is taken and used by Amazon as a cloud database, it's not the free and open source version. It's a fork of a fork, because they have considerations in order to use it with, acidic integrity at scale that the people who are just doing all this stuff for free either don't want to or don't have the time to consider and bake into the products. So it's always about the edge cases. And when someone takes a body of work and makes an extension or a module or whatever, it's because they've got some special situation that's not the everyday situation of everyone already using the product, or it would already exist and be part of the core package or the core library, the way it's distributed. A lot of things have core libraries, or it would be part of a third-party package that you could either find in GitHub as free and open source software, or perhaps even still buy it. And there are new business models coming into existence because of the extreme popularity of free and open source. Just because you're using free software doesn't mean your database is going to manage itself and avoid all those many pitfalls. Oh, back to the pitfalls of databases. So if you can help it, don't use databases. Or more accurately, perhaps use local databases that you don't even feel like you're using a database. Again, lines of distinction are being blurred. How? Because in memory, while you're using Python, you've already got dictionaries. They're called variables. You've got a place you stick a value that's data, it's put somewhere. You've got a base of data. Of course, when your computer loses power or the program stops executing, it's gone. So you write that data somewhere. And it is, for the most part, getting committed to hardware. Even if it's all in RAM, what is RAM but hardware that's running somewhere? It might just be one copy of the hardware, so you don't have redundancy, and it might be a piece of hardware that's been partitioned out to you under a cloud system like OpenStack or the Elastic Computing Cloud, but it's still hardware. There's no such thing as a virtual machine. It's just a machine. It's some portion of a machine, but a machine nonetheless. So the stuff that's running in RAM, random access memory, the fastest type of memory that's the closest to the processor, is generally lost when power is lost. It's the equivalent of your short-term memory, your memory in your head, in your conscious memory through the day. Everything that happened to you through the day is floating around there. It might already be kind of fractally compressed and barely retrievable in any form already than abstract notions, but still it's there. And when you go to sleep, your brain's going to build its index. just like a real database that creates shortcuts in the relationships it knows to exist between tables so that when you look things up, they're faster. So does your conscious brain do that across all your neurons, collecting up those new memories and experiences, committing those things to your long-term memory when you sleep overnight. It's not that listening to things in your sleep helps you learn. It's that being exposed to a lot of really scrumptious, brain-stimulating stuff during the day purges you to commit interesting bits of it to long-term memory, because when you go to sleep, those are going to resurface, remanifest in your thoughts, be symbolically connected and linked with many other things. Your dreams are going to go wacky. You're probably never going to remember it, but parts of your brain that you don't have every day, direct access to, things that are several layers away from your conscious thought, are sorting and organizing and putting stuff away and adding to collections of recognition patterns so that when similar things happen to you again in the future, it will trigger off the memories that are associated with that. And that is a lot of what life is about. You hook that up to an inverted donut that's rolling along, sucking matter from this world into itself, expelling the matter it doesn't need, extracting the parts it does, redistributing and strengthening the mobile walking donut. And that is life, or at least that is animal life, because it's the mobile part. Sometimes this is done with sticking roots into the ground to get the material substance and leaves into the air to get the energy from the sun. So, two basic forms of life. Of course, there's others, there's fungus, and there's our viruses life questions, but plants and animals. Plants are mobile donuts, where substance goes through the middle and energy and material substance is extracted. And plants that generally stay still, going up and down, drawing their ground material substance from through the roots in the form of minerals as opposed to proteins for the human body and animal bodies, and energy in the form of sunlight from the sky through chlorophyll, and that's instead of us eating bread and sugars. So, where did that take us all? Oh, dreams, recalling things, and memories. So the mobile donut knows how to be a better mobile donut and knows how to get more of the resources from its environment by being able to trigger off increasingly rich, interlinked collections of memories when patterns of recognition through your senses of sight, smell, taste, and especially even combinations of multiple ones are activated in the future. So you want to remember something? Go to an unusual setting, eat an unusual food, talk about an unusual topic to a person you don't see all the time, and that is going to make a profound, memorable experience, which is why a lot of people live to travel. And I'll tell you, I'm not one of them. I've got a dear friend who's the reason I'm here in New York today, who is, and I respect his approach tremendously. But I am an existentialist. I believe everything that's important is up here in your brain, because all you got is these senses that are taking information in from the outside world and allowing it to, the virtual machine concept again, create a virtual copy of it, your best understanding of the world around you, pieced together with great levels of redundancy. The dry programming people can take the fact that they don't have many levels of redundancy. You want to know about redundancy in information? Google up the Africans singing drums and compare it to, say, Morse code, and compare some systems in order to layer upon each other and to make sure mistakes aren't being made, so that there's checksum redundancies and all that kind of nonsense, are not always terse. They are sometimes quite verbose, the opposite of terse. And great programming is not always one way or the other, but entire programming languages do lend themselves to these styles. Specifically, Ruby lends itself to dry, don't repeat yourself. If you have to write it more than once, bam, turn it into a method, go object-oriented, do lots of reuse. Carry those attributes and program code around with you inside your objects. You use them so much. Then there's wet. We enjoy typing, and that would be Perl. The Perl programming language has so many ways of skinning the same cat that they have obfuscation contests to make it so that you cannot even see what the program's doing, that you do it in such a ridiculous, roundabout, obtuse, and unnecessarily convoluted way. And the Perl people tend to enjoy that. And it's more language-like than pure mathematics. Don't repeat yourself tends to be more purely mathematical, seeking the one true truth, the one true canonical answer or piece of information. Whereas redundant people want to make sure the idea is conveyed accurately across many different mental models, and so that, like, if you have to reboot society, you've got a lot of examples, and if that one lighter doesn't light, you know 8 different ways to make fire. So I'm somewhere in the middle. I'm not a Perl, we enjoy typing totally person, but I'm certainly not a dry, don't repeat yourself person. I do land somewhere in the middle because I really enjoy typing so much, but I try and get all that typing and thought processing out in my journal. Not real programming code, but just captured ideas in that one continuous text file that is MikeLevinSEO.com that just I keep appending to forever, chronologically reverse, so it reads just like a blog from top down with the latest at the top. I get all that out of my system there. I exercise my Vim typing skills. I repeat blocks of programming code that's already in GitHub and even now a Jupyter notebook. And that's triple redundancy right there. And I do this so that now I can make my code as sensible as possible. That's neither completely dry, because I do see the necessity to repeat code sometimes, for simplicity's sake, for readability's sake, for having things done right where they're being done is implied. Building APIs and wrappers around every last thing is the recipe for completely baffling yourself about how things work, because you gotta mentally hook this up to this, to this, to that in your mind. And if the programming language just makes sense and uses just the right level of abstractions in all your packages, looking at stuff that you just write out as if you're writing sentences but you're using Python is not so redundant. A little bit redundant, but not so much so that you should go out of your way to externalize every piece of repeated code. Am I making myself clear? Am I making myself clear? Well, there you have it. I love Jupyter Notebook. It is rewiring my head, as the very, very, very rare tool does. In memorable history, those rare tools being Git, the code control system, and the associated GitHub website, Vim, and all the associated VI derivative text editors that you can just sit down and use, the Linux platform itself, and also Unix. BSD is always an option, and their command sets in particular, and the good parts that you really should know and need to use every day, and how you can be a sysadmin and know DevOps and deployment stuff, and sprinkle in a little bit of computer science. Understanding Unix and the reasons for things is understanding one particular flavor of computer science where a perfectly good file system abstraction is used to pipe information out of one program into another. And there's a whole philosophy surrounding just how flexible, granular, general, and specific a Unix program should be, like ls and cat, and that stands for list and concatenate. And it's a real inspiration for how software should be written. It's a good system to look at and learn from. So that's Linux, Vim, and Git so far. And I would naturally put Python into that category. I have used and lived in and delved into and tried to master various other programming languages, but they weren't Python. Let me tell you, it's something else entirely. And there's a reason why every last thing that has a complicated API around it, written in some other language or compiled into some black box, is getting a Python wrapper around it. Everything from every Amazon service, again through that Bodo library, to Fortran itself, and MATLAB, and everything else that you might want to interact with, but it's not going to be re-implemented in Python natively because it doesn't make sense to. So you write APIs around it and you wrap it, and you don't have to learn anything new, not even how to write concurrent, because Python is so powerful that if the specification, the reference specification execution engine as provided by python.org, colloquially known as CPython, which is just python.exe to all you Windows people, can be tossed out the window and other ones used in its place that has different core assumptions, like PyPy, which essentially does an optimized C compile before it runs. So instead of the .pyc files that leave in large levels of dynamicism where lists can be mutable, changed in size and shape and how nested they go and how large the data inside of it, while it's running, while the Python execution environment adapts to these crazy changes that could even be changing the new code that's running. So it's very self-referential, potentially self-modifying in a very Lisp-like way. People that use those Lisp languages like Scheme and Clojure are going for these types of advantages of metaprogramming, they call it. Python has a little bit of metaprogramming, but especially when you're using the reference runtime engine, CPython. But if you want super tweaked out performance, use PyPy. That's PyPy, not to be confused with PyPI, which is PY capital PI, which is the repository system. So there's PyPy, the executable runtime engine that compiles things to super optimized C code. A souped up version of the .pyc files that even the reference spec, the Guido van Rossum official version uses. That uses a P code pre-compiled version for the very flexible Python virtual machine. The compiled exe is less flexible with a PyPy for performance. For example, lists no longer are mutable. I might be getting that a little bit wrong. It's certainly Euphora that makes lists no longer mutable, or ND arrays under the often used NumPy package. So when you're using NumPy, you've got the global interpreter lock, and you can't do concurrency. Big problem for Python. Lots of people curse Python over this. Enter Euphora. It turns out large classes of parallelizable tasks do not need to be thought about by the user. The equivalent of the compiler, or the just-in-time compiler, can see these parallelizable hotspots, bottlenecks within your code, and automatically do a map reduce process over as many processors as you're willing to throw to the task without you having to think about it. So all the classic Python you ever learned directly applicable in the massively parallel concurrent world without you having to learn a new thing. Now, where this doesn't help you is where human optimization would be more advantageous, where it's not just the pure map reduce concurrency things, but things where cleverness and human thought are required, because you know you can collect this information on average before you collect that information, and you know to put things into special wait states that the user is willing to tolerate while information is marshaled and serialized and all that. But that is for systems programmers who need to tweak out their concurrent optimizations. And then you would use programming languages like Google's new Go language that's being written by Ken Thompson, one of the inventors of the modern information world, the inventor of Unix. And he's helping make the Go language for Google, because they live in that edge case. They have high performance, large scale system software that has to just keep churning data through at the rate at which their available hardware can reasonably accommodate. So when Intel puts out those 80 core things, Google's going to be right there, and the Go language is going to break down and send out tasks like breaking copies of yourself apart into 100 pieces and having them all working at once, and that's wonderful. And then the rest of us are not pulsing brain aliens and can just code in nice single-threaded appearing classic Python code, even under Python 3, even with the async IO library previously named tool up there to assist you with concurrency, and wonderful libraries like Tornado and Torpedo and all these crazy things that have solved all the concurrency problems, and Euphora that have truly solved all the concurrency problems on Python need not be thought about, because you swap out the runtime engine, the compiler, the execution environment, whatever you want to call it, with one that is optimized for automatic parallelism, concurrency, and you're golden. So that is the world of Python. You never hit a brick wall, and if you do, there's not one, not two, but three probably separate individual endeavors going about solving that problem, making Python the perfect language for that specific problem domain, because people just love using it that much. And so there, I went on a long Python ramble thinking about the game changers. And there's not much more game changers in my recollection than Linux, Python, Vim, and Git. Some might argue for tmux. I'm kinda, sorta coming around to it. I'm gonna have to dabble in the GCC toolchain, the GNU Linux compiler, because I will like to optimize some C here and there, even if it's only the exact exes or the exact QEMU executables that I need for Linux, because I still believe in the lightweight approach, the bare bones approach, the embedded approach. But I'm putting all that aside for my day-to-day work, where I need to chug data around like it's no big deal. And to that end, I'm using IPython Notebook or Jupyter Notebook as the user interface. I'm using the native Python libraries and packages where it seems sensible, particularly the Shelve API, which turns any Python object, like a dictionary, into a persistent object, committed to hard drive like a database between turning your machine off and everything. And all you got to do is make sure that write back occurred and that the file is closed, and your data is there the next time you turn it on without having to even think about SQLite or DBM or any of the other things that might actually be back-ending it. But all you think about is the Python API. It's like an object relational model in the SQL world where you don't have to think about the real SQL that's behind it. But Python's full of that stuff. And sticking with the native ones is always a good idea, because the third-party APIs are going to stick as close to them as they can, like NumPy does to lists and to lists really, with its ND array, and like Pandas does to NumPy, and like the Shelve API lets you map a Python dictionary to Redis or Amazon S3 or MySQL or almost any other database backend. So use Python native objects, and if you don't, just use those optimized immutable ones that are great for parallelizing and number crunching, and you'll be golden. And as you can see from all this talk, next generation SEO, it's around the corner. Tons of people are flocking into the other fields where fuzzy SEOs can still be effective. They're already almost all in the field of social media. More batches of them are going into, AdWords management. The Google products are being made more interesting. There's influence management, community management, influencer relations, community management. It's endless. Earned media. There are just so many fields. Content, the creation of content, the creation of infographics. There's so many subdivisions of SEO and so many places for the fuzzy SEOs to go. They're all being pushed off into that, and that's great. We need them. We need people to man the tools. I'm a tools person. I'm a technical SEO. Well, yes, I will delve into the data itself. I'm not all about the tools. I am now embracing that data side of things, and I'm embracing the tools that have been created and now exist on the Python platform to assist data scientists with their data science. And I've really been awakened to, I've had my eyes opened to this whole incredible world of NumPy and Pandas and Euphora and PyPy and Jupyter Notebook in particular, which is just one of the best things on the internet today. And I recommend it to everybody. I recommend listening through to every single episode, and then I recommend listening through a second and a third time. And I recommend supporting his sponsors, and I recommend buying the books of the people who appear on his podcast, and I recommend taking his lesson that I haven't signed up for it myself, but it's only like $69 for lifetime access for like 6 lessons that take you progressively up. And I might have the numbers. I apologize to you, Michael, if I have it wrong. But through the 6 levels of projects that you should tackle to do everything a startup needs to do and can use Python for, like email list management and the whole checklist of business tasks. So anyway, that's my ramble today. What are we? Almost 35 minutes on this one. And that was fun. Maybe this is my thing. Maybe I'll get into these video casts and podcasts and start getting sponsors. And I'll try not to give up my free-flowing, non-edited style, because most of the time lost is through editing. And while I do believe in quality, I don't believe in quality at the expense of my time when I am the raw data feed source, and I am perfectly capable of putting it out there and making it accessible to the rest of the world. In fact, Google is transposing the language behind this very video right now as we speak, and it will be probably yet one more data source that you can hit as you spin through and pull down my videos and all the metadata associated with it, probably forgetting about the videos themselves, except maybe taking thumbnail samples every minute so that you can apply some machine learning algorithm to spot things that might have happened in the video, and all these other wonderful, delicious data science tasks that we're really on the edge of, because Anaconda makes a predictable Python and supplementary library code execution environment on your Windows OS X or Linux machine, and Jupyter Notebook gives you a wonderful interface to that language, and I spoke plenty about Python itself, and it creates a rapid, interactive, experimental, and exploratory and accountability system, which, especially when combined with GitHub and other channels you can push this stuff out on, like I'm going to do medium.com and excerpts and announce everything you do over the Twitters, you can start to see and then figure out what to write about and the topics to cover next by taking data in from the Twitters and the YouTubes. You can start to see next generation SEO being data science. Thanks for joining me. Hope to talk to you soon, and don't forget to subscribe.